Okay, welcome back, grade 11s. We're going to start week 7 with our final 2 lessons in our trig functions unit. And this particular lesson is on 6.6, where we're going to be modeling the equation from a graph. So this lesson, I have 4 different pictures. If you printed the lesson, that'd be great. And what we're going to do is we're going to fit a sine curve and a cos curve using AKPQ to come up with what would be the equation that would give us the same picture. And then, of course, knowing the equation, you can then answer future questions and predict future values. So I have a method or an order that I think is the easiest way to do it. And we're going to use that order of how to get A, K, P, and Q. The first one that I suggest is to get the amplitude, because there's a set formula to find amplitude, and you might as well use that formula and get your A value first. So in example 1, it says find the equation of the graph using sine as your base. Okay, we don't even care whether it's sine or cos to start with, because amplitude is always found the same way regardless. So here we have a sinusoidal graph. We notice that the y-axis goes up by 1, so it's important you look at your scale. And the x-axis, it looks like 30 degrees, 60 degrees, 90 degrees, so every notch is 30 degrees. The x-axis doesn't have to be in degrees all the time. Actually, that's actually very rare that it is. So this example happens to have degrees on the x-axis. So just paying attention to that. So in the first case, let's get our A value. Okay, so step 1, get your A value. And we know that amplitude is equal to max minus min cut in half. So the max value here on this graph is 3, and we're going to minus -5. So some people can just eyeball it and figure it out, but this way you'll always get the right answer. So 3 plus 5 is 8. 8 divided by 2 is 4. So the amplitude is 4. So that means when we go to actually fit in, if you remember, I'll use x or theta, it doesn't really matter. So we have to solve for the numbers A, K, P, and Q. Finding the A value first, super easy. So we know now 4 goes in front of the graph, the function. Whether it's sine or cos, it doesn't matter. What I suggest you find next is actually the Q value. So we're getting the parts that affect the y, the vertical, over and done with. Because once you know A, and you know what your max is, because you see that right on the graph, max subtract your amplitude will take you to the middle. Because remember, the amplitude is the distance from the midline, the axis, which is better known as Q, to the max, or the midline to the bottom, the trough. So if we want to get our Q value, we just have to go max minus amplitude, and that'll take us to the middle. So the max is 3, and we're minusing our amplitude of 4. So that means my midline, everything's been shifted down. The equation of my axes is y equals -1. So I suggest as soon as you find it, you draw a dotted line across, and that really indicates now the middle of the graph vertically. So we found A and we found Q pretty easily. The next thing that I suggest you find is K. So I'll just move over here. So the K value would be the next thing I suggest. And to get your K value, I suggest you go using your formula. Period equals 360. And again, it's always 360 for sine or cos, it doesn't matter, divided by K. So that is your general formula. So that means when I want to get K, I'll bring K up and the period will go down. So I'll flip-flop those two spots. So 360 stays there, divided by the period. The period comes from the graph. So you pick a point and you look to see, when do I see that same point again? So what is the width of one cycle? So you can go from peak to peak, 1, 2, 3, 4 squares, 30, 60, 90, 120 degrees. You could pick any point anywhere on the graph and follow that point until you come to it again. So the beginning of the downward bump, in other words, Well, that would be over here. Again, 120 degrees. So it looks like the period off the graph, if I went from there to there, is 120 degrees. That's one cycle, from there to there. So K then would equal 360 divided by 120. Well, that should go in 3 times, should it not? So we know that K value is 3. So now I have my A, I have my K, and I have my Q. So the last thing I need to get is my P value, my phase shift. So this depends on whether you're talking about now sine or cos. So this is now when it matters, whether you want to model this graph using a sine function or whether you want to model it using a cosine function. And it depends because that's going to dictate what you consider to be the phase shift. So let me explain. If you're considering it to be a sine graph, what you're looking for is where did your original 0, 0 end up? So if you remember, regular sine starts at 0, 0 and it goes up from there, right? That's regular sine. What we're looking for is the beginning of the upward bump. So beginning of upward bump. So if you don't remember what I'm talking about, sine starts at 0, 0, then 90, 1, then 180, 0, goes like this, and then it comes under, and then it finishes, right? So that's regular sine. What we're looking for is what happened to this point right here. So it's the start of the upward bump. Now, because this is a repetitive graph, it's periodic, you have many choices, and they all work. So you notice that your 0, 0 was on your original axis, but now the axis has shifted down. So using now -1 as your midline, where does the graph start the upward bump? Well, he starts it right there. That's the beginning of the upward bump. But so is right there. So 60 degrees right, 180 degrees right, 300 degrees right. These are all the beginning of the upward bump. So what has happened is we could say, oh, the sine graph was shifted right 60 degrees, or maybe it was shifted right 180, or maybe it was shifted right 300. And it won't matter which one we pick. So right 60, for instance. That would be an option. So if we were to put all of this together, what it would look like would be f of x equals 4 in front, then sine, because we were basing it on a sine graph, then the k value, which was 3, then theta or x, whatever you want to refer to it as, the x-axis. And then I'm saying right 60. So if I want the person to go right 60, I'm going to put a minus and then a 60. And then close it up and then go -1 at the back. So that would be one version of an equation that would fit this graph. But I'm going to say or, because again, we didn't have to choose the 60. We could have said still 4 sine 3 bracket x. We could have said right 180. So -180 would also work. They give you the same picture in the end. Or what if instead of picking the beginning of the upward bump, we picked the beginning of the downward bump first? So you know how sine goes up first. Well, what if we flipped it and sine was going down first? So you see right here, 0, 0, which is now dropped down to 0, -1. What if we chose no phase shift? So if we chose no phase shift, what we have to then account for is that there was now a reflection, though, in the x-axis, because now the bump goes down first. Just like if we picked 120 degrees right, it's a reflection because it's the downward bump, then the upward bump, instead of upward first, then downward. So if we choose no phase shift, so 4 sine 3x -1, so no phase shift, no p-value, in other words, we have to remember to put a minus to show that it's going to go down first instead of up first. Okay, so obviously multiple right answers. And just like we chose sine, first, if we were going to do cosine, so for cos graph, which is part B, what we're looking for instead of our 0, 0, we're looking for what happened to 0, 1. What happened to the peak of the first bump? So if you remember what cos typically looks like to start with, cos doesn't start at 0, 0. Cos starts at 0, 1, then 90, 0, and then 180, negative 1, and it comes down like that. So we're looking at what happened to that first peak for cos. Where did our 0, 1 go? Well, he either went down here and was flipped upside down, or he could be right there, and that would have been a 90-degree shift right. So again, you have options. We could go right 90, or we could go right 30. But if we pick the right 30 option, we're down instead of up. So it's a trough instead of a peak. So because we're right 30 and it's at the bottom instead of the top, we have to remember to include a reflection in that case. So what would the situations look like? G of x equals, the amplitude would stay the same. This time we're going to use the word cos, not sine. And it's going to be a 3, then the bracket. Let's do right 90. X minus 90, and then minus 1. Or g of x equals negative 4 cos 3, and then right 30, x minus 30 degrees, squared off, minus 1. So again, there's 5 options, and of course there's an infinite number of options to come up with an equation that would fit this graph because of the repetition of it. All right, so let's try the next one on the sheet, and you can see that it's the same 4 steps over and over. We're not going to do as many options now for the other graphs. We're just going to pick maybe 1 or 2 and move on. Now notice the x-axis here. Again, it does look like degrees. Again, every box is 30 from the looks of it. So again, it wants it in sine first, and then it wants it in cos. So that's what we're going to do. The first thing that we look for is the amplitude. So again, amplitude equals max minus min cut in half. So our A value is going to be 5 minus 1 cut in half, 4 on top, 2 on the bottom, which gives us 2 overall. So that means our axes, our Q value, is going to be our max minus our amplitude. The max was 5 and we're subtracting 2. So that means our midline is at 3. So that helps me now visualize what happened to the original x-axis. Everything was shifted up 3 units. And you can see we're 2 units to the top and 2 units to the bottom, because 2 units is our amplitude. So we have our A, we have our Q. Next, I suggest you get your K. So K is worth 360 divided by the period. Right after I rearrange, period equals 360 over K. K equals 360 over period. Now, the period here, though. We need to make sure that we pick something that's really easy to see. So if I start here, it looks like not quite the bottom, just a little bit before the bottom. I have to get to that same point again. Could be 90 degrees, potentially. Another way you could try to think about it is how many cycles, 1, 2, 3, 4. So it's 4 cycles, 4 complete cycles in 360 degrees. So in that case, to figure out the period, it takes 360 degrees to see 4 complete cycles. So that means it must take 90 degrees per cycle. And we see one complete picture in 90, another complete picture, another complete picture. So our period is 90. So K equals 360 divided by 90, and that goes in 4 times. So our K value is 4. Now to get our last number, our phase shift, that's the part where we have to remember that in this case, we're looking at it as a sine function. So because we're looking at the sine function, where's the beginning of the upward bump? We're looking for our new 0, 0. That's what you're looking for. So you look along your axes, your new axes, which is at a height of 3, and you look to see where does the upward bump start. And if it's a good x value to read, then you pick that one. So I'm reading across. This is the beginning of the upward bump. I look down, looks like 30 degrees. I could also pick 120 degrees. Both of those would make a lot of sense. So 30 degrees right, that's an option. So that would mean f of x equals, all together now, 2 sine 4 bracket x minus 30, close your bracket, and then plus 3. Or, again, it didn't have to be the beginning of the upward bump. I could have picked the beginning of the downward bump, but that's a weird number there, and I'm just kind of guessing 67.5. It looks like every box is 30, so 75, maybe 75 degrees right there. If it's too odd to read, then obviously don't gamble and try. So maybe use the 120 as another option if you wanted to, or the 210. Those would make more sense. Now, if we're going to use cos instead, then that means we have to redo the phase shift option because everything else stays the same except for cos. In cos's case, except for the phase shift option. So we're looking for our new 0, 1. Where is our peak? Well, our peak is right here. So what does that look like? Kind of hard to read. Same as the bottom. We could pick the trough, but we're not even like in the middle of a square. We're kind of over. So what we then have to do is do a little bit of fractions. So if I was to choose this point right here and do a reflection option, I have to realize that every square is worth 30. So half a square would be worth 15, and this is half of that. So half of 15. So it looks like 7.5 degrees right, but that would include a reflection. So that would be, for instance, g of x equals 2 with a negative sign in front because it starts down instead of up. Cos bracket 4 bracket x minus 7.5, and then plus 3 at the back. Now, if you picked this point up here, then it would be 7.5 degrees past the halfway point of 30 to 60. So halfway between 30 and 60 is 45. 45 plus 7.5. So 52.5 is what I would expect that point up there. So you could have said 52.5 degrees right, no reflection in that case because we're starting on the highest point. The way that I got that 7.5 again, each square is worth 30, half a square is worth 15, half of 15 is 7.5. All right, 2 more. So maybe you want to give some of these a try yourself to get your AKPQ and then come back and check with me. That would be a good use of your time. So just pause, look at the picture, get your sine graph, get your cos graph, and then come back and check. All right, so let me just quickly go through these. So now you have something to check your answers with. All right, amplitude. Amplitude equals max minus min cut in half. Again, looking at our x-axis, these are just random numbers. We don't know what they represent. They could be days, so first day, second day, third day after a certain reference point. It could be years, maybe number of years since 2000, for instance. So this would be 2001, 2002, 1999, 1998. They could mean anything. It could be hours of the day. So amplitude equals max is -2. We're minusing the min, which is -4. And we divide by 2. -2 plus 4 is 2. 2 over 2 is 1. So 1 unit down from the top, 1 unit up from the bottom means our midline is right there. It should be at -3. So our Q is going to be our max minus our amplitude. Max was -2. We're going to minus 1 from that, and that's where we get our -3. So we know our start number, we know our last number. Now we have to get our K. So K is equal to always 360 for sine or cos divided by the period that you read off the graph. 360 over the period. Now, we're not quite at the top of the bump. And it looks like it takes me 6 units to get to that same position over here. So not quite the top of the next bump. That's one option. You can pick a number that you see really well. So for instance, right here, I can read that right really well at 2. When do I get to this exact point again? Looks like right there, 8 units later. So from 2 to 8, that's one cycle. So that means it's 6 units wide. So the period is 6. And 360, of course, divided by 6 is just 60. Now, that 60 can be anything. So right now the units don't make any sense because we don't know what they are. So our K value is 60. Now for sine, so the last one is our phase shift. And again, it wants sine first. You're looking for the beginning of the upward bump. Well, follow along on your new axes, which is down here at -3. You could pick this point, you could pick that point, you could pick that point. Again, it's where the graph starts to go up. So maybe it's 5 units right. Maybe it's 1 unit left. So 1 unit left. You can go left. You don't always have to go to the right. Let's do 5 units right. Again, giving you options. So if you picked 1 unit left, the beginning of the upward bump, you would say f of x equals, our a value is 1, so I'm not even going to bother to write it. Sine, our k value is 60, x, 1 unit left. If I want the person to go left, I'm going to put a plus sign there, then a 1. And then we're going to put a -3 at the back. If we did 5 units right, again, I'm not going to put the amplitude of 1 at the front. It's already there. Again, 60, 5 units right, x minus 5. Now, these aren't degrees. I don't know what they are, so I'm not putting any units in there. And then a -3. If you wanted to pick the beginning of the downward bump, you could have said 2 units to the right and then done a reflection in the front. You would have put a minus sign. If you are picking cos, now you're looking for where your 0, 1 ended up. So now we're looking at the graph, but instead of looking for the beginning of the upward bump, we're looking for where is our peak. Well, a peak is right there. There's another peak. We can also look at troughs. So where's the bottom? The bottom is right there. Now these aren't in great locations because we're just kind of estimating. It looks like it's at 0.5 or 6.5 or 3.5, -2.5. Any of those would work. You just need to pick one. I'm going to say, just to be different, 3.5. So cos this time, 60 to the right, 3.5. And then put a -3 at the back. But because I picked the bottom instead of the peak, you got to reflect that one if you pick that same phase shift. So I picked this guy. If you picked positive 0.5, you wouldn't put a negative there because it's the peak where cos normally is. All right, last case. So this guy seems to have a bigger amplitude. Again, we want sine and cos. So amplitude is equal to max minus min cut in half. So what do we have here? The max is a 5, the min is a -1, so we're minusing a -1. So that's 6 over 2, better known as 3. So the amplitude is 3, which means our axis is going to be our max minus our amplitude. And that is, again, 5 minus the 3. So we hit at a midline of 2. Always nice to visually see it on the graph. So I suggest you draw a new dashed line across at that new height. And you can see the entire graph has been shifted up 2 units. 3 units to get to the peak, 3 units to get to the trough. All right, our K value is going to be worth 360 divided by whatever our period is off our graph. 360 divided by. Now, I'm just picking, I don't know, this point. I could pick anything. Maybe a peak to the peak. Why don't we go peak to peak? There we go. How many units does it take to go from peak to peak? Our scale goes by 1, so that's making it easy. So 1, 2, 3, 4, 5, 6, 7, 8 units. So it looks like our period is 8 units, whatever those units are. So 360 divided by 8 is 45. So 45 is our K value in this case. Now, again, because it wants sine as our first graph option, and it's not always going to be sine first. Sometimes it'll just ask for cos right away. But because it's asking for sine, we're looking for where did our 0, 0 go. So our P value is going to be the beginning of the upward bump. Well, right here, 1 unit over to the right is the beginning of the upward bump. But so is 9 units over to the right. And so is -7 units on the x-axis. That's also the beginning of the upward bump. So I could say 7 left, and that would be f of x equals 3 was our amplitude, sine 45 x plus 7, close bracket, and then plus 2 as an option. So I happened to just pick this one because that was the first beginning of the upward bump that I saw. If you were picking the beginning of the downward bump again, you would put a negative sign in front of the 3 in the front. Now, if you're going to do cos, we might as well pick the first peak we see. Most people are going to pick 3 units right. Most people. But you could have also picked 5 units left. You could have picked 1 unit left and then reflected. You could have picked 7 units left, reflected, or 7 units right, I should say, reflect. Or in this case, 11 units right, no reflection. So g of x equals, since I picked 3 units right and it's a peak, there's no reflection. So it's just the plain 3 in the front. Then it's a cos, don't put a sign there. 45 bracket x, 3 units right. Right means minus 3, squared it off. Again, I don't know if it's degrees or whatever those units are, so I'm not putting them down. And then a plus 2 at the back. And that's it. So we just came up with both sine and cos equations for these 4 graphs. So definitely an important skill, because obviously the purpose of getting these equations is so that now you can insert different values and make predictions for future numbers that the graph doesn't show. And that's exactly what modeling does when we collect data. We try to use that data to make future predictions, but we need an equation in order to do that. So let me know if you have any questions, but hopefully you'll follow these same 4 steps over and over again and you shouldn't have any problems.